Hi, I'm J.R. Bonfoy, a system engineer at Samtec. Today I am at DesignCon 2021 in Samtec booth. We are going to look at a live demonstration showing how Samtec Flyover Twinax Cable assemblies allow designers to extend signal reach and density, enabling 112 gigabit per second PAM4 performance. Let's begin by me showing you the signal path, and then we'll check out the performance of the channel. It all begins with AlphaWave's AlphaCore multi-standard SerDes, which generates PRBS31 data at 112 gigabit per second PAM4. These signals travel from the silicon through about 1 inch of differential traces in Itera MT40 material to a Samtec Bullseye high-performance test connector system located opposite the chip on the back of the board. The signals travel from the Bullseye system connector through 20 inches of low-loss microwave cables, which terminate to Samtec Precision 185 connectors. These 185mm Precision RF connectors are mounted on a Samtec SI evaluation board. The signals travel through another 2 inches of PCB trace to the solder ball termination of a NVAM-C connector, which is a Samtec NovaRay high-density board-level connector. A NovaRay cable assembly, an NVAC P series, mates with the board-level connector and carries the signal through 6 inches of 34-gauge high-speed, ultra-low skew Twinax cable to the panel mount interface. The fully shielded NovaRay I/O cable assembly, the NVAC E series, plugs into the panel and moves the signal through 2 meters of 28-gauge high-speed, ultra-low skew Twinax cable. The signal goes back through a second port on the panel to another NVAC cable with an additional 6 inches of ultra-low skew Twinax cable and back to a second SI evaluation board. This demonstration has 8 different interconnect transitions and runs 3.5 meters. But the total loss for the entire signal path, including all cable assemblies and PCBs, is approximately 35.7 dB at 28 GHz. Using AlphaWave's user interface and analysis tool, let's take a look at the performance of this channel. We can see the eye diagram captured at the receiver after equalization. The margins are wide. The vertical bastop is showing the bit error rate for all 3 levels of the PAM4 signaling. The bit error ratio is calculated around 1e-7 for this long reach channel. The performance is well within specification by several orders of magnitudes, providing the designers plenty of margin. The histogram plot and the scatter plot shows the probability density estimate of the PAM4 signaling, showing really good separation and signal-to-noise ratio. As the data rate requirements increase, the system designers struggle with propagating these signals through lossy PCBs. Samtec Flyover solution allow them to extend the signal reach and density by routing signals via ultra-low skew Twinax cable instead of lossy PCBs. If you have any questions about this demo, please email us at seg@samtec.com. Thanks for watching.